Hello, Cappuccino. It is time for some notes on solving a system of equations using elimination. So you'll notice this is one of the problems that we did do in class. So we're just going to formalize it for our notes if you haven't yet already. So I have the equation 2x plus y equals 4 and x minus y equals 11. If I add these two equations together, and we saw that this is allowed, we can add the entire left sides of the equations together and set it equal to the entire right sides of the equations. If we do that, we get 2x plus 1x is 3x. And then I have positive 1y plus negative 1y is 0y's. And that equals 4 plus 11 is 15. Well, 3x plus 0 is still just 3x. And so what number times 3 gives me 15? Well, that would be 5. 3 times 5 is 15. I can also divide both sides by 3 if I can't figure it out just in my head. I can divide both sides by 3. 3 divided by 3 is 1, and I'm left with x is equal to 15 divided by 3, which is 5. So a lot of times students think, yay, I'm done, I found x, but no. This is a system of equations. We have to find both x and y. So now I'm going to find y. And in order to find y, you can use either equation, but I like to use the one that has more positives in it. I find that a lot of students have problems with negative signs. So it's better if you use the one with the positives so that you don't run into trouble with the with any negatives. Okay, so I'm going to copy down that first equation. And now I'm going to substitute in 5 for the x. So where the x is here, I'm going to change that to a 5 because I know that x is equal to 5. So I have 2 times 5 plus y is equal to 4. 2 times 5 is 10. 10 plus y is equal to 4. Subtract 10 from both sides of the equation to get y by itself. And I get y is equal to negative 6. Now, one last thing that's a good idea is to make sure that your answer works in the other equation. Okay, so if you remember back to our raisins and walnuts situation, we found a pair of numbers that you could use for one of the equations for raisins and walnuts, but that didn't mean that it worked for the other equation. So let's make sure that this pair of numbers actually does work in the other equation. So I'm going to call that my check. So I'm going to check my solution in the x minus y. Does that equal 11? So my x is 5 minus my y is negative 6. 5 minus negative 6, well, minus a negative becomes a positive. So 5 plus 6 equals 11. So it does check. So my solution, we write it as a coordinate pair. We always write it in alphabetical order. X comes before Y in the alphabet. So 5 comma negative 6, just like the alphabetical order. So there is the first example. Okay, notice in this first example, when we added the equations together, the y was eliminated. But it doesn't always have to be the y. You could add the equations together and have the x be eliminated. So we're going to see that happen in the second example. So here is my second example that I'm going to do. 4x plus 3y equals 10, and negative 4x plus 5y equals 6. So I'm going to go ahead and add my two equations together. 4x plus negative 4x is 0. 3y plus 5y is 8y. And 10 plus 6 is 16. So remember, 4 plus negative 4 is 0, so there's 0 x's, which is the same as just 0, because 0 times anything is 0. All right, that leaves me with 8y equals 16. 8 times what is 16? Oh, 8 times 2 is 16. So y is going to be equal to 2. In case that doesn't occur to you, you can solve it by dividing both sides by 8. So I'm going to divide both sides of the equation by 8, and I get y is equal to 2. Now I have y, but I don't have x. So this is kind of the opposite of what happened in my first example. Here I solved for y first, but now I need to find x. So I am going to say find x. And again, I look at my choices for equations. I like to use the one that has more positives in it. I find it easier to avoid any negatives. So I'm going to copy down that first equation. And I'm going to substitute in 2 for the y. Be really careful that you're putting it in for the right number. I have the y this time, so I have to replace the y with 2. So I have 4x plus 3 times 2 is equal to 10. And if I multiply that out, 3 times 2 is 6. Now I'm going to subtract 6 from both sides of the equal sign. I'm trying to get my x by itself. X is being multiplied by 4 and added by 6. So I'm going to reverse that. Minus my 6 to get my 4x by itself. 10 minus 6 is 4, because 6 minus 6 was 0, right? 4 times what is equal to 4? Oh, that would be 1. 4 times 1 is equal to 4. In case that doesn't occur to you, go ahead and divide both sides by 4. Whatever x is being multiplied by, divide by that same number so that you end up with just 1x. 4 divided by 4 is 1. So there it is. So my solution, I'll write it over here. I don't have room on the other side. My solution, it looks like, is going to be 1, 2. Again, alphabetical order. X goes first. Doesn't matter that we solved for y first. Doesn't matter. When we write the solution, it's always alphabetical order. X and then y. Okay, and I can also do my check, make sure it really works. So I'm going to check it in the other equation. Negative 4x plus 5y equals 6. And I'm going to substitute in my numbers for x and y. So negative 4 times 1 plus 5 times 2. Does that equal 6? And you could go ahead and grab a calculator and do that on the calculator. So I'm going to have negative 4 parentheses 1 plus 5 parentheses 2. So I'm just typing in exactly what I see right here. There it is. I'm going to hit equals, and it says it's 6. Yay! So it checked. I got it right. I checked it. So my solution is 1, 2, and I checked it. I know it's correct. So a lot of people find the elimination method to actually be a lot easier than the substitution method. And later this week, we're going to see how we can use the elimination method for problems that look a little bit different, that have a few more extra steps to it. All right, that's it. Hope this worked for you.